So now I'll be going ahead and adding some assets here to make our work a little better. So I'll be adding some grass texture here to our floor, just so we can make it a bit more visible. So let's go ahead and create a new folder, and this is going to be called images. And here I'm going to import our first asset, which is going to be a simple grass texture I made myself. So now Godot has loaded that image and has set up inside of here. So let me select my floor here. Let's go to our texture here. So inside of the geometry tab here, we're going to open our material, go ahead on its albedo, and here you can see the texture which has the icon. I'm going to now drag and drop the texture of my grass inside of that slot, and it's going to be applied here in the world. And whenever we run the scene, this is how it's going to be displayed. Next, I'm going to go ahead and simply disable some things like the specular. I do not want the specular because this is a terrain. And I'm going to simply go to UVs, and I think I'm going to increase this to a bit. And let's also do something else. As you can see, there are no shadows here. So let's go and select our light. And let's enable the shadow to be a directional orthogonal one. So we can actually see a bit more of the shadow. And of course, we'll not be able to see because we have pushed the camera far away by 100 meters, and the max distance of the shadow is set up to be 100. So if you increase this, you're going to now see the shadows. And if you increase it too much, it's going to dim the shadows until it's no longer visible as a optimization. So let's go ahead because of the fade start parameter here. So let's put 200. So now you can see somewhat of the shadows, and of course you can fine tune this. But know that whenever we move the camera, this value is going to change a lot. Let's keep something around 150 or 200. And you can say this, and you can set this option as you want. So now we have some basic stuff to work with. So now we have our basic scene here with a floor, some tents, and a 3D camera. So now let's go ahead and start by adding the code to our camera to make it move and respond to our inputs. Now, first, we need the inputs themselves. So the way you can add inputs to a Godot project is by going ahead on Project, Project Settings, and here we have a bunch of settings. And also notice this option here, which is pretty important, which will allow you to have a lot more access under more options here of your project. So let's go ahead on the Input Map section, and let's add here some inputs we'll be using for our camera. So let's add some actions, which is the name of the input we'll be using, not the input itself, but rather what we're going to be called those inputs. So it's like a group of inputs. So let's add as input underscore action underscore mouse click left, and let's add this new action. And I'm going to double click, copy this to add a mouse click right. Let's also add a input action for ask. And let's also add a new one, and let me just copy these to enter. And these ones are going to be adding some functionality. So let's go ahead and close it. We'll be adding more as we need. So let's save the scene, and let's go now back to our camera code. So the first mechanic we'll be adding is to pan the camera whenever the mouse touches the edges of the screen. So let's go ahead and do just that. First, I'll be adding a constant here, which is going to control the margin of the panning. So let's add a constant, and let's add as pan margin. And constants always are on the uppercase letter. Let's add them as floats, and let's put 5.0. So this size actually represents pixels and not meters, because this is related to the 2D camera. So we'll be using this to match the pixels to trigger the panning of the screen edge. So let's put here a simple comment, just we know what that is for. Alright, now let's go ahead and build the function that is going to handle this. So we can add this as a public method because we can also allow other objects to call it. You can also change this as you want. So let's add the new function called camera pan, and this is going to require us to pass delta to normalize the movement. and this function returns nothing, so void. So the first thing we want to do is to analyze the position of the mouse. So let's do a new variable, which is going to be calculating the mouse position, which is a vector2, and is going to be equal to our viewport. So we're going to get the viewport and get the mouse position through there. And there we go. Now we have the mouse position stored under a variable. Now we also need to get the viewport size, which is going to be a vector2, and it's going to be equal to our viewport, and we want to get its visible rectangle and its size. So get the size of the viewport. So now let's do some couple of checks that's going to actually move and pan our camera around. So if our mouse position on its X is going to be less than our camera pan margin, which is the constant we have built up on the top there. So if it's less than that, we'll be adding some velocity to our camera. So and I actually forgot to build the variable that's going to control the velocity of the panning. So this variable is going to control to whether the camera moves to the right, to the left, to the up, and this is basically the direction of the movement of the camera. So we call it as cam movement and velocity. And this is a vector3, which will be generate and assign it as 0. So now I can actually edit that, and it's actually movement and not movement. So camera movement velocity x position is going to be now equals to -1 multiplied by delta. So delta here is used to normalize this movement because we'll be calling this function based on the process, and process runs by your FPS. So you have a higher FPS count, you're going to run more function calls for process, and if you have a lower FPS, you're going to run a much more slower. So if you don't multiply this movement by delta, the function is going to be called more times when it has more FPSs, resulting in the camera moving more when you have more FPSs. So we multiply by delta, which is the difference between FPSs, to normalize this movement. So in order to make sure it stays constant despite the amount of frames per second your player has. So that is why we multiplied by delta. Now next, let's do our mouse position. If its Y is going to be less than our camera pan margin, we're going to be adding its camera movement velocity on its Z to be equal to -1 multiplied by delta. So why Z and not Y? Because this is a vector3 and we are moving the camera in the 3D space. And as you can see here, Z points towards the front or the back and X to the left or right. And Y is actually upwards. So we want to move the camera on the X and Z, not on the Y. That's why we are using Z and not Y here. Next, let's add if our mouse position, its X position is going to be higher, our viewport size on its X minus our camera margin. Then the camera velocity movement is going to be on its X position is going to be equal to 1 multiplied by delta. And let's simply copy this line by using Ctrl+Shift+D, and let's change here some parameters. So the Y is going to be actually the size of Y here, and here we can also change this to be Z. So doing this simple function here, we now have a camera pan movement. Now let's copy this function to our process here function, and let's pass here our delta. So because we have an underscore, let's delete that to use as a parameter. So just by doing this, we are capturing the mouse position, checking for the viewport size, and we actually change it here. We also could define this as a constant because this is not changing, but let's keep it as a var. So by each process we are running this function, which gets the mouse position, the viewport size, and we actually calculate the panning movement using this code here. So whenever we run the scene, we now should be able to pan the camera whenever our mouse touches the border here, minus the panning movements. And of course, nothing happens because I did not actually am editing anything. So we are editing a variable but not applying it. So we need to apply that. So I forgot to build another function here. which is going to be a private internal function for this RTS camera. So this function is going to be called a apply movement velocity. So this is going to basically apply the movement velocity if we have any. So first, let's check if we have actually a movement velocity to begin with. So we're going to be checking if it is not equal to vector 3, 0. So if it's not a vector 3, 0, if it has some movement, we will be using it to move the object. So let's move the camera by using the built-in function called translate object on local space. And we're going to be moving the 3D node based on the camera movement velocity. So with this, we now should be able to move the camera, and we also want to reset the camera velocity, otherwise we'll be constantly setting it up. So let's reset this back to 0. So if you have some velocity, apply that as a translation to move the object in local space and reset it back to 0. On the next process frame, the process repeats itself and we actually have movement based on each process. So whenever our mouse now touches the edges of the screen, we should be able to get some movements. And of course, nothing happens because I do not call this function. So let's copy this one, go to the process and add it whenever they end here. Now it should finally work. And as you can see, whenever we move the mouse down here, you can actually see some movement. But it's very slow, so we have to increase the speed. So let's go ahead and whenever we apply the movement velocity, let's multiply this by 4. I think it's going to give the effect. And we can actually multiply this by something bigger. Let's multiply by 40. Yeah, now it should work as expected. So as you can see, whenever the mouse reaches the edge of the screen, we move the camera. So a simple pen function to move the camera around. So let's go ahead and keep adding to this. So something, if you notice now, let's add a option to confine the mouse inside of the 3D viewport. So you notice that we can actually pass the mouse outside of the screen and we can actually move the camera. So let's go ahead and add a function that's to confine the mouse inside of this viewport. So let's go ahead to our main code. So this is the code for the main node of our 3D game. So we have our main code here. So let's select it. And whenever we start the game, let's set on the input singleton a mouse mode to be equal to our input mouse mode confined. So we're going to be basically confining the mouse inside of the viewport. So whenever now we run the project, you're going to see that my mouse cannot anymore extend and move outside of the running window, which is cool, but now my mouse is trapped in here and the only way to get out of this is by pressing Alt F4. So now we need to add some inputs to control that to have a more easy time. So let's go ahead and add a overrides to a built-in method for this node, which is going to be for unhandled inputs. So whenever we have a unhandled input, we want to check if this is the input we'll be using to change the confined mode of the mouse. So let's do code here that whenever we press ESC on the keyboard, we get out of this confined mode and we free the mouse to be actually out of the viewport. So let's do if the input singleton has detected an action being released, so is action just released, and here we're going to pass the input action ESC, which you have defined here under project settings, input map. And let's actually add the inputs to these actions because currently it's only the actions. So on enter, let's add an event. Let's press enter here. And on the ESC as well, let's press ESC. And we are actually capturing the inputs for these actions. So on the mouse click right, let's go ahead and select mouse, right mouse button, and for the left one as well, left mouse button. So now we have inputs that's going to trigger these actions. So whenever we listen through them on the code, like here, if input is action just released, and this is the action we are listening for, which is the input action ESC. We're going to be detecting it right now. So now this function is going to work on this check here. So if that is the case, we're going to now handle this input, which is done by grabbing the viewport and set the input as handled. So this is actually something a little more advanced, but I'm going to be explaining you briefly. This function is going to be using inputs that are not handled by other nodes. So in Godot, automatically some inputs can grab the inputs of your commands. So when I press the spacebar, if a node has some code that uses it, it's going to consume, and the input is not going to propagate to other nodes inside of your tree. By using unhandled inputs, you're going to be asking for inputs that were not handled by any other node. So basically, if an input is not being used by any other object, we'll be using for this function. And whenever we do this, we actually have consumed the input with this node. So now the input is not going to propagate to other objects. So whenever we press ask, if we have not used that input, we're going to be now have consumed this input, so we no longer propagate to other objects. And now we're going to actually do an action, which is basically to set the inputs on the mouse mode to be set up as a input mouse mode visible. So these variables here are predefined inside of Godot. If we go ahead and select them, so if you hold Ctrl and click on any property or function inside of your code, it's going to try to grab some reference or information about it. In this case, whenever we do that, we're going to see that it has opened the documentation for the input class, and it has showed us on the enum sections, so basically constants available under the mouse mode, to have these ones. And these are the behaviors it has, so makes the mouse cursor visible if it's hidden, can hide the mouse, you can capture it inside of the window, you can confine and hide it. So this is used for FPS, and there are some behaviors here if you want to use it. So whenever we start the game, on our main window here, we set the inputs to be confined, and whenever we press ask, we're going to set it to visible. So visible basically makes the mouse cursor visible and set it to be free, whereas before it was confined to the game window. So all of this code is basically to do the following. So whenever we are on a scene, we are confined inside of the viewport, and the mouse cannot escape from it. Whenever I press ask, now the mouse can actually move outside of it. But our pen function doesn't know this and still pens because it detects that the mouse has passed the viewport. So let's now detect if our mouse is confined or not inside of the viewport, so our camera does not trigger that. So let's go ahead to our camera function, and whenever we want to apply the panning of the camera, we want to now detect if the mouse is actually confined or not. So let's add a condition here. If our input singleton has detected from the mouse mode, so we're going to grab the mouse mode from the input singleton. If its type is not equal to the input, mouse mode confined. So if our mouse is not confined to the game viewport, we actually want to skip this function entirely. So this in turn is going to make the mouse not to be confined. So we will not be able to pan if the mouse is not confined to the viewport. So whenever we run the scene, you're going to see that whenever the mouse is confined to the viewport, I cannot escape with it, and the function calls for the camera to continue panning. Whenever I press ask, now the camera no longer pans and my mouse is free to move around. So now let's do a code to whenever we click on the viewport, we get inside of the confined space again. Because if you leave at this, you no longer has power to actually edit. So let's go back here and let's go to our main one. So now let's add a new input unhandled to detect whether we press enter or not. So let me just check if I have that input set here. So we have the input action to be enter. So we can check him here. So if our input singleton has detected an action being released, and this action is enter, or, so let me add another condition here. If that is the case, or another one, which is the one we're going to be adding, the other one is if our input singleton has detected an action being released, which is going to be the mouse left click. So if that is the case, we're going to be doing something. The first one is to copy this line here. So basically we'll be handling the input and set the input of the mouse movement. So setting the mouse mode, and of course I have done two indentations here. Oh, of course I forgot to put an OR keyword there. So let's set the mouse mode here to be now confined back again. So basically we are saying if you press enter or left click, we are going to grab the viewport, set that input from unhandled to be consumed so it no longer propagates to other objects, and set the mouse mode to be confined back again. So whenever we run our project, we have now confined the mouse inside of the viewport of the window. Whenever we press ESC, we have exited and the camera no longer pans, and if we click inside of the game viewport, we now have confined the mouse again. And this is what it looks like. So yeah. Now let's add a new code that whenever we press ESC twice, we're going to be exiting the project. This is a little shortcut to avoid having to press here the stop button. So this is going to be pretty simple. So whenever we press ESC, we set the mouse mode to be... So whenever we press ESC, let's add a new condition here. If the input of the mouse mode is going to be equal to a input, so if it's confined, we're going to set it to be free. However, if it's not confined, it was already free, we're going to be exiting this scene. So let's do a get free, and we're going to be quitting the scene. And this is how you can exit the game. You're going to access the main tree of your game and asking for a quit function, which basically quits the application at the end of the current iteration. So now if we run the scene, so it's confined inside of the viewport, the mouse, whenever I press ESC, the mouse is free. And if I press ESC again, because the mouse was already free on this condition, it's going to get the tree and quit the project. So pretty handy stuff now we can use to editing the project. So as you can see, now we have some inputs here that deals with that. So yeah, pretty cool if you want to do this. So now let's go back to our 3D camera and add the possibility to move the camera by pressing the keyboard control keys. So let's add those inputs here so we can detect them. So here let's add an input action for the movement of the camera. So we're going to be called camera, and here we're going to be adding a couple of names such as camera forwards, camera backwards, camera left, and camera right. So to move the camera forward, we can press W or press the up keyboard. If we want to move the camera backwards, first we want to use the S or the downwards key. The left is going to be A, or if you press left on the keyboard. And for the right, if you press D on the keyboard, or if you press the left keyboard. Now we have those input actions have assigned with the corresponding inputs. Let's close this. Let's go back to our code here, access our camera. And let's do another function here, which is going to be our camera movement. So let's build a function called camera move, which is going to also be using delta to normalize the movement of the camera. And let's do now if our input singleton has detected an action being released, which is going to be the camera moving forwards. And we're going to copy this so we can actually use it here. And of course the indentations we don't need. So if we press Shift Tab, you move the indentation backwards, and if you press Tab, you move them forwards. And now let's add the new lines to these. And let's do here the following. So we want to set the camera velocity movement to be its z equals to -1 multiplied by delta, and we can move the camera forwards by doing this. So let's copy this, which is basically the function we'll be using for all of these. So in the case of moving forwards, that's -1. To move it backwards, we need to move it on the +1. To move the camera to the left, we need to set its x to be -1, and to move it to the right, we need to move the x towards +1. Now we only need to update the inputs. So let me just delete this and let me teach you something very cool. If you press Alt and click, you're going to be adding multiple code edits at the same time. So as you can see now, if I press Ctrl Shift and right, I can now edit multiple times of the lines. There we go. And if you want to reset it, just click again and you're going to be releasing. So pretty cool stuff. So Control Space to auto-complete this, and we want to move the camera backwards now, because we already moved it forwards, and this one is to move the camera on its left position, and this one to move it to the right. Now the last thing remaining is just for us to copy this function here towards our process 1. Now we want to apply this after we pan the camera, and we want to pass delta. And finally we apply the movement velocity. So now if we run our project, whenever we press double A or D keys, you're going to see that the camera is going to be moving. And if you press left and right, up and down, yeah, it also moves. But of course, I forgot to set up something. And as you can see, it's only when we release the key and not when we press it. So this is, of course, just a minor one on this one. So instead of actually being released, we want to detect it if the action is being pressed. So actually the right code is action just pressed and not released. Now if we run this scene and move, it's actually the same thing. So it's actually the action being continually pressed, so it's action pressed and not just pressed. So these minor differences is very important. So it allows you to have custom code for the inputs, but as you can see, it can be very confusing sometimes. So input is something very complex. So we have inputs for them being pressed, for them just pressed, or just release it. All of those are different commands. And if you control click on it and go to methods under the input singleton, you're going to see there's a lot of stuff here. And the ones we are accessing, which is called action just release, here they are. So the just release is whenever it has started pressing, is action just release is whenever the user stops pressing, or is action pressed, it returns true if you are pressing the action. So yeah, I have a video on inputs and I'll be covering this more in detail, but handling inputs sometimes get quite confusing. So now the function should work as we want. So whenever we press, now it's going to move the camera. And we can move with the double SD keys, with the panning of the camera, and also with the arrow keys. And if we press ESC, we can exit the camera and move the mouse freely to edit something as we want. And if we click inside of the viewport, we constrain the movement back again. And if we double press ESC, we're going to exit the project. Okay, pretty cool stuff we have already built. Now let's add the rotation capability to our camera. So we want to rotate the camera whenever we press E or Q.